You ready, Connor? Because you're here on time? In physics, every measured quantity, every single thing that I teach you is either a scalar or a vector. So this year and next year, anytime I show you something new, I'll give you three things. I'll tell you its symbol, because we never write out whole words, we use abbrev. I'll tell you the units that it's measured in, and then you'll hear me tell you whether it's a scalar or a vector. Scalars have magnitude, that's a fancy word for size, only. And then I have here, for example, we're going to come back to that in just a second. Vectors have both magnitude, size, and this is the important part, direction. Direction. Some examples of scalars. Time. How much time has passed? 81 seconds. It doesn't make sense to say, how much time has passed? 81 seconds north. Mass. That object has a mass of 51 kilograms. It doesn't make sense to say that object has a mass of 51 kilograms up. Volume. Area, work, energy, speed, distance, voltage, a bunch. Some examples of vectors of physics quantities where direction makes a difference. Acceleration, I'm going to abbreviate it. Those of you that have your driver's license, it makes a difference whether you're accelerating forwards or backwards. You get a different effect. Force. It makes a difference which way you push on something. Push on it one way, it'll move in a certain direction. Push on it a different way, it'll move in a different direction. And the fact that I had to answer that by saying the word direction tells you it's a vector. Okay. Momentum. That's an M. Momentum. You don't know what that is yet, but we'll get there. Momentum is what we'll look at to study collisions. It makes a big difference whether you get rear-ended or whether you get hit head-on. Trust me, rear-ending in a car crash is much easier on your body than getting hit head-on. The direction matters. Electric field, gravitational field, magnetic field, current, torque, velocity, displacement. You'll just slowly memorize what they are as I give you new stuff. In fact, I have a little chart here. So, famous scalar, time, which we typically symbolize with the letter T. Vector, acceleration, which we typically symbolize with the letter A. Velocity is a vector, which we symbolize with the letter V. Mr. Dewick, it would sure be nice if there was a dumb, easy way to remember that velocity is a vector. Mr. Dewick, if you were a good teacher, you'd have an easy way for us to remember that velocity is a vector. Yeah, I got nothing. I suck. You're on your own. Sorry. Speed is a scalar. Mr. Dewick, it would sure be nice if there was an easy way to remember that speed is a scalar. Mr. Dewick, if you were a good teacher, you'd probably have a dumb, easy way for me to remember that speed is a scalar. I got nothing. I'm sorry. You're on your own. Distance is a scalar. Displacement is a vector. Now, vectors are either written in bold font when you're typing up a textbook. and you want to show velocity as a vector, you make it in bold font, but that's irritating to do. Yeah? Not yet. Have patience. When you're writing with a textbook, bold font is easy. Handwriting bold font is a pain. And so when we're handwriting, if I want to show that velocity is a vector, I put an arrow above it, although over the years it's evolved into a little half arrow like that. In fact, up here on your acceleration, there should be a vector symbol. There should be a vector symbol on the V. The symbol for velocity is V with the vector. The symbol for speed is V without the vector. It's velocity minus direction, speed. The symbol for displacement is D with a vector. The symbol for distance is D, no vector. By the way, that's technically wrong, and I'll explain that to you in a couple of seconds. But when you want a vector, to show that it's a vector, we put an arrow on it. Mr. Dueck, what, Reese? If we forget to put an arrow, will you take marks off? No, but you know what? You'll lose marks on your own because you'll forget that it was a vector, and at the very end, you'll forget that direction made a difference to your answer, and you'll get the wrong answer. So anytime I'm in vector land, I'm very conscientious about vectors. There's also a whole different branch of math for vectors. It's called vector mathematics. Everybody in your heads, what's 6 plus 5?
11.
That's scalar math. In vector math, 6 plus 5 can be 11, but 6 plus 5 can also be 1, and it can be every single decimal value between 1 and 11. 2.35, 3.92657, everything in between. How does that work? Take Physics 12. That's a preview of coming attractions. Okay? So we'll use the vector symbol, the half arrow, for vectors. If you don't see a half arrow, assume all I wanted was the magnitude, the size, and I didn't care about the direction. Did I answer your question that you had, by the way? Did I answer the question that you asked me earlier about symbols and something? Patience. No, miles per hour, please. Stupid Americans, not a chance. Distance versus displacement. Distance is how far an object has traveled. You may have noticed that in physics we tend to abbreviate, so we're going to use a symbol for distance. We're never going to write it out. The correct proper symbol for distance comes to us from Isaac Newton because he used it. Now, he did a lot of his work in Latin, and so the correct symbol for distance is a lowercase s. I hate it. I hate it. The reason is, first of all, lowercase s also means seconds. And to me, it also looks too much like the number 5. So I'm not going to use it. You can lightly put an X through it. However, if you go on to university physics, especially if you have a British prof, they'll use the S. Some textbooks will use a lowercase x for distance because they want you to imagine that you're moving on the x-axis, where left is negative and right is positive. And you'll see that sometimes this year, especially if I steal a resource from the internet and couldn't change the graphics. But I'm not going to use that. I'm going to use the wrong symbol, which is easier to keep track of. I'm going to use a lowercase d, which technically is wrong. But I'm going to use d for distance. Why? Because it's easy to remember. The reason it's wrong is also because a lowercase d in calculus means something very important and very different. It means you're taking a derivative, and that's hugely important. But you know what? We're going to use the d. Yep. What are the units for distance? Yep. And distance is a scalar. Displacement. Displacement is an object's change in position. Displacement is an object's change in position. Symbol, well, S with a vector bar above it, technically. But often you'll see, because we have a symbol for change in, you'll often see it written triangle X, except we don't call that a triangle. What do we call that if we're a little bit nerdy? Okay, delta X, and delta is the abbreviation for change in. We're going to use that this year, both because, hey, nerdy Greek, and it's a shortcut, and it tends to abbreviate. Or you might see delta D, or because Mr. Dewick is lazy, he'll often just put a D with a vector sign above it, displacement. It's a good system, Mobeen. It's nice shorthand, but it also means you have to pay attention and read carefully. Sorry. It's the trade-off, but it's less writing, so I'm in. Just as a little thought experiment. Sorry for those of you at home can't see this. If I start out right here, and I'm going to walk, and each step that I take is 1 meter. I'm going to go 1, 2, 3 meters this way, 1, 2 meters this way. What was my distance that I traveled?
5.
5. What's my displacement?
1 meter.
1 meter direction to your right. Except for those of you who are looking at everything. And in fact, because all of you are sitting in different locations, one of the things we'll often do is we'll say, let's define the position so all of us are talking about the same thing. When an object starts moving, it's useful to be able to describe an object's location. To describe the location, hey, imagine like a meter stick that goes in either direction, where left is negative and right is positive, or imagine a number line. Objects to the right of 0, we can call those positive. Objects to the left of 0, we can call those negative. Now that's arbitrary, and in fact, Eric, later on this year, you're going to see sometimes we'll let left be positive because the math is nicer, just so we don't have to deal with negative numbers. Sometimes we'll let down be positive because the math is nicer. But for now, we'll let left be positive, right be negative. No, let's phrase that differently. We'll let left be negative, right be positive. Am I positive? Apparently. Example 1, a bug walks along a little number line. It starts at A and walks to B. You know what? Here's how we can show that. We can draw an arrow from A ending at B. Then it turns around and it walks to C. That's a pretty good picture. Part A asks, what distance did the bug walk? Sorry, I think you're right. 14? How could you find that? Okay. In your homework, if you do it in your head like that and just write the answer, I'm good. In our notes, just so that when we're studying, you know what the heck we did. Let's go 4 plus 10 equals 14 meters. You do not have to do that in your homework. If you can do that, you're great. All right. What's the bug's change in position, or, fancy word, displacement? First of all, the symbol for displacement is that. No, that's distance. That's displacement. Or you could do a delta x. What's its change in position?
-6 meters.
Or you could write 6 meters left. I'd take either of those. Which one of those is less writing? I'll probably go with the first one most of the time. Here's where I would be fussy. Here's what I would not take. Don't write this down. Don't write this down. If you said -6 meters left, because isn't negative left technically right? 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 Don't do that. Go one or the other, but I'll be fussy. I would take a half mark off, even though I knew that you meant to the left. Negative left is right. Right? Turn the page. Little thought experiment. Suppose that you run 3 different paths from location A to location B. Path 1, path 2, path 3. In which of those is your distance different from your displacement?
1 and 3.
I didn't hear you.
Path 1 and 3.
1 and 3. In fact, we have a saying. We say the shortest distance between 2 points is a straight line. That's what path 2 is showing you. So if you don't make any changes in direction, if you go in a straight line, your distance, all lines are straight, but you know what I mean? Your distance and your displacement will be the same. But yeah, path 1 and path 3, you'll have a different distance. Your displacement would be that. Your distance is all over the place. I said it's helpful to be able to describe position. So it says use the number line below to give the positions of the objects, and don't forget the units. What is the position of the heart? Isn't it in your thoracic cavity on the picture? What's the position of the heart? I would take 4 meters right, but that's too much writing. Get it? See how I said that? Too much writing? 4 meters right, too much right. Huh? Come on. Zing! Some of you missed. That's pretty good. Sorry? And you could say positive 4. Don't write this down. Don't write this down. I have no problem if you do that, but I would argue, Simi, isn't that automatically assumed to be positive? If you do that, I'll figure it out. In fact, I'll probably say positive 4. The diamond, okay, sorry, for Luke, or 4 meters right. Sure. What's the position of the diamond? The diamond. Whew. What's the position of the cross? I'll still put units on there. 0 meters. That's a location. So that's position, and I said that displacement was change in position, so we can use arrows to represent a displacement. We did that earlier with the bug question. I kind of snuck that in. A bike moving along a number line from a position of 4 meters to negative 3 meters, for example. A bike moving along a number line from a position of 4 meters to negative 3 meters. We'll often use a variable, d or x. Heck, I'll call this x. You know what? Let's write it underneath, Mr. Dick. I'll call this x. I'll call this x. Mr. Dewick, using the same letter. Connor, what we do is we bring in the subscripts. We use an I for initial and an F for final. Christina, you're in the back of my room. For my I for initial, I will almost always put a little curl on the lowercase I because you can't quite see the dot from the back of the room, but I want to make sure you know that's a 1. That's an I, even if you can't see the dot. Okay? It's just a habit I picked up over the years, so if you're wondering why I curl my I's, it's to make sure it looks like a little italic lowercase I. So here's my question. What's the displacement of this bike? Sorry? Thought I heard someone say something. Go ahead, Lyndon. Displacement negative 3? I think I disagree. By the way, what's the final position of this bike? Negative 3. What's the change in position? What's the displacement? 7 is wrong. Negative 7. Yes? Because we moved to the... Mr. Dewick, is there like a mathematical way to get... What if the numbers are bigger and I can't do them in my head? Okay. To find the change in anything, change in is always final takeaway initial. Lyndon, I'm coming back to you. What's my final position as a number? Minus. What's my initial position as a number? If you go negative 3, take away 4, do you also get negative 7? Yes. So if it's bigger numbers that you can't do in your head, you're going to hear me say all year long, hey, what's change in anything? Final minus initial. What's change in anything? Final minus initial. Example. example 4 says, draw an arrow showing an object that moves from the -4 meter position to the +5 meter position. Okay, here's X initial. Here's X final. There's the arrow. And then it says, what's the object's distance? Double check your math. Not 10. 9? Right? From -4 to +5 is 9? Yes? What's this object's displacement? Of 9. And the positive I would read out now because that would say to me 9 meters to the right. All right, for Luke. Or 9 meters right. Example 5 says, draw an arrow that shows an object moving from the 7 meter position to the 1 meter position. So I guess here is location X initial, here is location X final, and my arrow would look like that. What's this object's distance? Sorry? I didn't hear. I think I heard it right, but I disagree. -6 is not correct. 6 meters because distance is a scalar. It doesn't care about direction. How far did you travel? 6 meters. What's your displacement? What's your change in position? There. Get the very subtle difference? It's subtle, but it's there. By the way, remember I said you could also find that by going final minus initial? Final minus initial. Does that also give you the -6? Yes, it does. Works. And now we can start to, now that we've talked about distance and displacement, we can talk about speed and velocity. Average is the distance divided by delta time, where that delta means change in. Harshpreet, did I write an English word there? Say yes. Did I write an English word there? Say yes. Too much writing. We can do better. As an equation, look up for a second. That would be velocity. Don't write that down yet. Ready? Now I'll make it speed. That's speed. Average speed, I tend to use a subscript of There is a symbol for average, but I'll show you why it's a problem in a couple of minutes. So average speed is distance over delta t. Stop, look up, don't write this down yet, look up. Because time is always a change in, it's always a change in, over the years we get lazy and we stop putting the delta because it's sort of understood, the same way as you stop putting a plus sign in front of a positive number because it's sort of understood. So, okay. D over T. I think that's on your formula sheet somewhere near the top row or second row. Yep.
Yeah.
Okay. Units. And now I can answer Linnea's question. What are the units for speed? We can figure it out. What are the units for distance in proper SI science units? Meters. What are the units for time in proper SI? And so our preferred units for velocity or speed are meters per second. Speed. Scalar or vector?
Scalar.
Before you turn the page. It is really worth memorizing what units go with which quantities. Have I told you that I don't like memorizing stuff already? So if I tell you something is worth memorizing, it's really worth memorizing! It really is. If, as you go through this course, every time I give you something new, you also memorize the units attached to it, it will dramatically cut down on your mistakes and your thinking. You'll be able to intuitively just do stuff. Trust me. So one of the things you're going to hear me say over and over is, it's worth memorizing the units that go with which variables, with which concepts. Now you can turn the page. Average velocity. Well, if average speed was distance over time, average velocity is going to be displacement over change in time, where that triangle means change in. As an equation, I can take the speed equation, which was dt, and I can vectorize it. Now velocity is a vector, and now displacement is a vector. What would the units for average velocity be? Well, what's the units for displacement? Really? Cool. Velocity, scalar or vector? Put your pencils down. Once you've written that down, look up. I said there was a symbol for average. There is. If you want to find the average of something, it's a horizontal line. Now the problem is, from the back corner where Mobine is, that sort of looks like the arrow. The other problem is, if I wanted to also make this a vector so that it was average velocity, I'd have to be able to do that, and I haven't figured out how to put two symbols above one letter on when I'm typing yet. So I'm going to do a subscript of av, if that's okay. Pick your pens up. Let's do an example. Example 6 says this. If the bug strip mentioned in example 1 took 30 seconds, average speed? B, what's the bug's average velocity? I'm going to introduce you to a problem-solving technique that I use. This is my fallback whenever I'm doing something brand new and I'm not sure what to do. Now, as you get good, Gurjot, you'll skip some of these steps. You will. But the problem-solving approach that I use is an acronym. We're going to write it over to the right. And the acronym that I use is a capital D, capital F, capital I, capital C. I say DFIC. When in doubt, DFIC. I don't know what to do, Mr. Duke. Well, have you DFIC yet? What do I mean by DFIC? The D stands for write out your data. And what I mean by that is look for numbers and physics words and write down what they are. You've written something down, you'll feel better. Trust me, you'll do better on the question. The F stands for find a formula from your formula sheet that has everything from your data in it. Write that down. Then the I stands for insert the numbers, insert the data. And the C stands for calculate the answers or crunch the answers. When in doubt, DFIC. And I'll show you what I mean. And again, Eric, as you get good, you'll start to take shortcuts. But anytime I get to a really complicated question, you'll see, heck, even in Physics 12, I start listing stuff that they gave me, because as I do so, it will also twig certain approaches, certain variables, certain things that I can do. Eric, in part A, what are they asking me to find? I'm going to write down V av equals question mark. That's my way of saying, what are they asking me to find? I put a question mark next to it. Have I written something down? Yeah, I feel better. Then I'm going to start to list my data. Now, one thing, Eric, they gave me is this 30. What are the units right next to the 30, Eric, my friend? So what is this 30 in terms of the variables that we've looked at so far? Is it that, or that? Let's write down t equals 30. Seconds. we have two more pieces of information, but they have to come from example 1, because it says, using the trip in example 1. In example 1, we found distance and we found displacement. Can someone go back? What was the distance that the bug traveled in example 1? 14? What was the displacement that the bug traveled? I think we did it in the same question. -6 meters? All right. Eric, what's this question asking me to find? Have I got an equation with average speed in it? So by the way, this is the list your data, the D portion of my approach. Now I'm looking for an equation. I think the equation is going to be VAV equals D over T. And it's going to be the non-vector one, the scalar one. Derek, what's the distance that this bug traveled? Eric, what's the distance that this bug traveled? I'm looking at the letter D and sticking it in front of your name for some dumb reason. Yes? What's the time that this bug traveled for? Okay, calculator time, folks. What's 14 divided by 30? You get 0.466666666666666666. Now, I'm going to write that down. 0.46 repeating. But just as a sig fig review, how many sig figs is this 14? 2. How many sig figs is this 30? Technically, how many sig figs should I go to? 1. Technically, I should say, is the 4 going to stay a 4 or become a 5? And I should write 0.5. I'm not gonna. But technically, I should. It's just that that's rounding off so much on this answer. Units for average speed. And then I usually put a box around my final answer. That's kind of like my touchdown dance. Lyndon, what's B asking me to find? Didn't we just find that? No, we found average speed, and there's going to be a difference. This is going to sound like a dumb question, Lyndon. Have we turned the page? Say no. Are we on a new page? Say no. Then you know what? I'm not going to relist my data. I'm not going to re-defic. I've got it all on this line right here. But if I had turned the page, I'd quickly write everything out again. Or if the situation had changed, if B said after 45 seconds, I might relist my data because that's a totally different situation. But has anything changed? No. So I'm just going to write what they're asking me to find, which is V with a vector sign, av equals question mark. I'm looking for an equation that has V vector sign, velocity, average velocity, and it's this one. Now, I think on your formula sheet, by the way, I didn't give you both the scalar and the vector. I think on the formula sheet, I gave you the scalar. Figure you can figure out the vector one from that. Yes? Fair enough? I think. Lyndon, what's going to go in for the D vector?
I don't know, wait, it's -6.
Okay, good catch. What's going to go in for the time? This one I can do in my head. I think -6 divided by 30. Double check me. -0.2? Which I can actually, because it ends there. I guess I can go to 1 sig fig now, which I'm really supposed to anyway, so that's kind of nice. Units, Lyndon, my friend. And then for Luke, or 2.2 meters per second to the left. Connor, in this equation right here, how many variables are there? How many equations does it actually contain? 3. And I'm about to show you one of the most useful skills I can teach you. It's called formula manipulation, the ability to rewrite an equation in your head. And if you wrap your brain around it, and the vast majority of you will, I will have dropped down your memorization in this course by about 80%. I will have done you a huge favor. It's going to seem a little weird at first, but trust me, I've done this for years. I'm going to push you into mastering it. So it says this, if V average equals d over t, what would be an equation for displacement and time? Since it wants two equations, I'm going to go like that. I'm going to start out writing the equation that they gave me, which is V av equals d over t. And I'd like to get an equation for displacement. What that really means is I would like to get the d by itself. How? What else is on the same side as the letter d? T. Where is the t? In the top or the bottom of the fraction? Is this t multiplying, dividing, adding, or subtracting onto the d? What does that mean? Dividing. So here's my question. How would I move it to the other side? If it's dividing on this side, how would I move it to the other side? In other words, the v would drop down like a domino, the t would get timesed onto it, and I could write this equals d, but we're used to seeing the thing by itself on the left-hand side. There's another equation. Now, I gave you that one on your formula sheet, but you're going to find as the year progresses, I will no longer give you all the variations of equations. I'll give you the one main one, and I'll say you can rewrite it in your head. If v equals d over t, automatically that means that d equals v times t. It has to. It's equation solving. Tristan, it also wants me to get this by itself. What letter am I using for time? I want to get the t by itself. Now, in the original equation, in this one, where is the t, top or bottom? Bottom sucks to do math with. But look, 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 look. Where is the t in this equation? Top or bottom? If it's not on the bottom, it's on the top. So this will be nicer to work with. You said beside the v, I totally agree. Mathematically, what's the v doing to the t? Adding, subtracting, multiplying, or dividing? So how would I move that v to the other side? So if I hear you correctly, you're telling me the d would stay where it was. It would just kind of drop down like a domino. Yes? I would divide by the v. Now, I could write this, but we're used to seeing the thing by itself on that side. So can I write t equals d over v? That's another equation. I don't think I put that one on your formula sheet, or did I? I don't think so. This idea, the idea that you can take one equation and rewrite it in many ways, is hugely handy. Now, it may seem a little weird at first, but Christina, trust me, by Christmas, I will give you, don't write this down, vf squared equals vi squared plus 2ad, and you'll glance at that and you'll say, oh, Duick, a equals vf squared minus vi squared all over 2d, and you'll do it almost boredly. It won't seem anything special. We'll get there. And that's a hugely useful skill. Otherwise, if I give you an equation with 4 variables, I'd actually have to make you memorize 4 different equations. Forget that. If I give you an equation with 3 letters, I'd have to memorize 3 different equations. Forget that. We can learn one and rewrite it. Don't write that down. Example 7. Josh, what's example 7 asking me to find?
A motorist travels.
Just read it to yourself. What's it asking me to find?
The average speed.
By the way, you're going to find in physics, although it's all word problems, they're way easier than math because it's pretty obvious what they're asking you to find. Almost always the word what or find appears in front of it. What did you say it's asking us to find?
The average speed.
You know what I'm going to do first? V av equals question mark. This is my DFIC approach. I write down what they wanted me to find. This is very similar, by the way, to the way I did unit conversions as well. Write down what they gave you. Here, write down what they want me to find. Now I'm going to read the question, and I'm looking for numbers and physics words. The first thing I see is the number 350. See it?
Yep.
What are the units right next to the 350?
Kilometers.
So what is that 350 in terms of my letters in these equations?
Distance.
Cool. I keep reading, and I see a 6. What are the units next to that 6?
Time.
Hours, so time. Okay. Now this question is actually a 2-part question. It says it wants the average speed in, what are the first units?
Kilometers per
and then in,
Meters per second.
you know what? Let's call this part A. Let's call this part B. Let's do part A first. I should put the units there. Now, the nice thing here is, what does it want the units in?
Kilometers.
Per?
Hour.
What did it give me the distance units in?
Kilometers.
What did it give me the time units in?
Hours.
You know what? I don't need to change anything. My equation will still work. Now, if one of these was in meters or one of these was in seconds, I'd have to do a conversion. What did it want me to find?
Kilometers.
What did it want me to find?
Oh. Average speed.
Looking for an equation that has a v, a d, and a t in it. There is one. This one, right? V equals d over t, and it's v average. Yes?
Yeah.
What's d in this question, Josh, my friend?
Oh, 350.
What's t in this question?
6.
And if you notice, looking at the units, it will be kilometers per hour, which is what part A wanted. 350 divided by 6. 58.33333. By the way, technically, this 350, how many sig figs?
3. 2.
3 or 2? 2. How many sig figs? 2. How many sig figs should I go to in my answer? 2. So I'm going to write this. 58.3 repeating, and I'll put an equal sign, and I'll go to 2 sig figs, kilometers per hour. Again, I'm not going to make you do all your answers to the correct sig figs, but I'll continue reminding you how to do it to the correct sig figs. B. In meters per second. There's 2 ways to do this. Linnea, I could convert this to meters. I could convert this to seconds, and I could do all this again. Or I could convert this to meters per second by using a unit conversion method. I'm going to do that method. I'm going to do the unit conversion because this one happens so often, we're going to come up with a shortcut for it. And it's because I want to give you questions that you relate to, and one of the speeds that you're all familiar with are car speeds, but those are measured in kilometers per hour. Most of you have clued in 50 kilometers per hour is what you do on city streets. 80 kilometers per hour is what you can do on sections of the Lougheed. 100 kilometers per hour is what you can do on the Trans-Canada. 110 is what you can do on the Coquihalla. You know these speeds a little bit. So I'm going to do a unit conversion. How did I start every single unit conversion always? What was the first thing I always did? Really? Write down what they gave me. Absolutely. So I'm going to write down 58.3 repeating kilometers per hour. I'm going to times. I'm going to do a fraction bar. It's going to go in this fraction bar then, on the top or on the bottom? Bottom. And I can put meters right there. What can I replace that there kilo with? It's 10 to the third, but you know what? I love the fact that you did it in your head and you said, you know, that's 1,000. And again, some of you had trouble with this on the test. The prefix replacement goes where the letter isn't, not in front of the K, where there is no K. That's where it goes. Some of you remember trying to memorize, it goes on the top or the bottom. No, 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 no. It goes where you don't have a prefix. That would give us meters per hour. We need to get rid of hours. Where's hours originally? On the bottom. So where's it going to go in my conversion factor? And I want seconds. Now, we could go from hours to minutes, but have you guys realized how many seconds there are in 1 hour?
3,600.
Most of you have clued in that there's 3,600. What am I going to do with that 1,000? Times or divide?
Divide.
What am I going to do with this 1,000? Times or divide? How do I know times? Where is it? On the? What am I going to do with this 3,600? Times or divide? Okay. By the way, have I gone on a good calculator rant with you guys? So you should be able to use your answer button right now, because I have that 58.333333333333333 stored on my calculator. Most of you, your answer button is either shift equals. For me, it's second function or shift right next to equals. If I hit that, that brings up answer, my previous answer. And then I'm going to go times 1,000. It's less typing and it's more accurate to use my answer button instead of typing 58 point and filling my screen with threes. And I get 16.20. 037, 037, 037, 037, 0. But I'm going to go 16.2 meters per second, because rounding off after in front of a 0 is a nice place to round off. Technically, I should go to 2 sig figs and say 16 meters per second. I want you to notice something. We times by 1,000 and divided by 3,600. That's really just the same if you combine those two as dividing by 3.6. So on the next page, at the top, we're going to write out a little shortcut. Over on the left, can you write kilometers per hour? Over on the right, can you write meters per second? And then, Youngjun, if you can draw a little arrow going this way, to go from kilometers per hour to meters per second, it's divide by 3.6. You still got time. Suck it up, Buttercup. Oh, and if I want to go from meters per second to kilometers per hour, what do you think I'd do with that 3.6? See how we wrote that? Now, what we just wrote there, I give you permission to also put that on the front page of your formula sheet at the bottom, because this is a unit conversion very often. This is one I don't mind coming up with a shortcut for. So on your green formula sheet, at the bottom of the page, put that. On your green formula sheet, at the bottom of the page, put that. In fact, later on, I'll give you an even dumber way to memorize that. I know that it involves a 3.6. I can never remember whether I'm supposed to divide or times. I figure it out in my head every time by being clever. Because I don't need to memorize it, I can figure it out. So far, so good, Kieran? Yeah? I know I've been talking lots, throwing lots at you. I like example 8. I like example 8. Example 8 is a nice question. And I like it not just because it's good physics, but because I have to be honest, I'm a bit of an echo nut. If I'm somewhere in the wilderness and there's an echo, I'm there for a while playing with the echo thing. Sorry, but I am. So it says this. Speed of sound is 330 meters per second. That's about right. Actually, the speed of sound varies. It changes based on temperature. It changes based on altitude, changes based on how much moisture there is in the air. So that's roughly, varies anywhere between 320 and 340 meters per second. 330 is good enough. Sheldon is shouting at the base of a steep mountain. If the mountain is 420 meters away, how long will it take before Sheldon hears his echo? Hey, Mike, what's this question asking me to find? I know I caught you zoning out. That's why I picked on you. What variable is how long? What do you think, folks? Time. You know what? Let's all of us write down T equals question mark. Mike, have we written something down? Do we feel better? Are we zoned in? Here we go. It's okay. I'm still picking on you for the rest of this question. You're going to be with me now. Now, Mike, we look at this question and we're looking for numbers and physics words. What physics words? I'll teach you those later. But for now, I see a 330. Yes? What are the units right next to that 330? What is that 330 then? Out of our variables in our equation, what is it?
Speed average.
Speed. Now, you also know, because they used the word speed right there, but even if they hadn't, I could have figured it out. It's a speed or a velocity. Is there a direction? It's a speed. You okay with me? So I'm going to write down V equals 330 meters per second. If you want to, you can put the little average there. You'll notice I'm getting sloppy and even dropping the average because right now it's all it is. So far so good, Mike? What's this 420? What are the units right next to it? So what is this 420? And for a candy, why is Mike wrong? Because he is. Why is this distance incorrect?
Because he didn't put meters.
Nope. I always pause. Think about this question. Why is that distance wrong? There's a candy available. My other two classes got it. I had one kid get it right away last block. Echo!
Because it's away from the initial.
No, units are fine.
The other direction.
No need for a direction here. We're in Scalarville. Okay. You know how an echo works? Yes? Are you telling me the sound is traveling 420 meters? How does an echo work? Darcy, what?
It's 840.
Why is it 840? Because the sound goes, hits the whatever, and then?
Goes back.
Now that's unique to this question, which is also why I like this question. There's a tiny bit of good thinking physics there that in hindsight seems obvious, but I saw you, right? Okay. Coming back now to my man Mike. Mike, I'm looking for an equation that has a T, a V, and a D in it. You know what? The only equation we got so far is V equals D over T. Mike, what are we trying to find? What are we trying to find? What are we trying to find? Loud and proud. What? Time. What letter is that? I want to get the T by itself. Where is the T right now?
Bottom.
Can you get your hand away from your mouth, Mike? Sorry. Where is the T right now? That sucks. Wait. Dividing by T on this side is the same as doing what with the T on this side? All of you right now go like that, and you can tuck the T in front or behind. Timesing on that side. That's a much nicer equation to deal with because no fractions. Have I got the T by itself yet? No. There's another letter next to the T. What's the letter that's next to the T now? What's the V doing to the T? Adding, subtracting, multiplying, or dividing? How will I move the V over? So if I hear you correctly, and I think I do, you're telling me an equation for time, which is not on your formula sheet, but which we can derive. The D stays where it is. You said I would divide the V over, and the T is there. You would be correct. Now, meters per second and meters, my units all match up. Somebody also said units don't match up. Actually, I think in the next question, units don't match up. We'll talk about how that works. But for now, it's going to be 840 divided by 330. Same as going to be 84 divided by 33. Can I do that in my head? Yeah, that's yucky math. And I get 2.5454545454. Okay. I'll write this 2.54 repeating. Mike, how many sig figs is 330? How many sig figs is 420? Technically, I should go to 2 sig figs. Okay, so I'll write 2.5 units time. Units for time. Seconds, right? Right? Okay. So I got number 9. Don't turn the page yet. We'll finish this tomorrow, but we'll get number 9 done here. Okay? Read the question to yourself. Hey, Jenna, what are they asking me to find in number 9? Ah, good, good. D equals question mark. I see an 18, Jenna. What's that 18? How do you know? You're right. It's meters per second. Because this time they didn't use the word speed in front of it. I glanced at the units. Meters per second, that's a speed. So V equals 18 meters per second. What's that 2.5, Jenna, my joy? How do you know? And now I had meters per second, and I have time in hours. I can't do the math like this. I either have to convert the hours to the seconds, or I have to convert the meters per second to kilometers per hour. Me to find how far will he travel in? You know what? I'm going to convert the meters per second to kilometers per hour. And then if I keep the time in hours, I'll get an answer in kilometers. I can do this. You guys can't, but I can. Haha. Let's convert this to kilometers per hour. How do I convert meters per second to kilometers per hour? Has something to do with a 3.6. Multiply or divide by 3.6. So 18 times 3.6. This is the same as 64.8 kilometers per hour. Well, the equals D over T. Jenna, my joy, I want to get the D by itself. What else is on the same side as the D? A T. What's that T doing to the D? Adding, subtracting, multiplying, or dividing? How will I move the T over? Yep. It's going to go from here. Now, you could write T, then V, but for some reason it's traditional to put the T after the V. Our new equation is D equals VT. Now, some of you will get good enough at this, by the way, that you can go straight to looking at your formula sheet without writing this, and I'm fine with that. In fact, I kind of want you all to get there. I like it if you can rewrite these in your head. Now we're going to plug and chug. V, 64.8. T, 2.5. And because it's kilometers per hour and hours, this will give us an answer in kilometers. I use my answer. 162. And then the last thing it says is convert that to meters. By the way, what's the shortcut to go from kilometers to meters? Have you picked up on that one? You should, because you're driving soon. How many meters are in a kilometer? It's 1,000. So 162 kilometers is 162,000 meters. You could do the full unit conversion if you want to, but trust me. And I multiplied by 1,000 in my head because I can. We'll finish this off tomorrow. Make sure you bring the lesson with you.